All right, this is second part of the asynchronous work, and let's share the. Okay, the first thing you have to review is type 1 and type 2 error. You just pause the video and you can just go through this. Well, maybe I create the flashcard, so take a look. So when an alternative parameter value is true, this is something new actually. All right, so these are the flashcard I made. When alternative hypothesis is true and we fail to reject null hypothesis. So what is it? So this type 1 or type 2 error, right? Type 2 error, okay? So we are focusing on both of them. Mainly you learn something new today is more like for this, okay? So what's the other one? So when no hypothesis is true and we reject no hypothesis. So that's most likely type 1 error, okay? The one thing we're going to learn, so you can take a good look of this from chapter 9-1, and you can just pause the video and you can just go through this, okay? Right, type 2 error and the power of the test. This is a new topic, okay? The significance test makes a type 2 error when it fails to reject null hypothesis. That really false. There are many values of parameter that makes the alternative hypothesis true. So we concentrate on one value, consider the potato chip example, okay? That involves null hypothesis P equals 0.08 versus alternative hypothesis P is greater than 0.08. If the true proportion is blemished potatoes and shipment was 0.09, we made type 2 error by failing to reject null hypothesis. Of course, right? Because fail to reject means we honor, kind of we have a favor to uh, uh, type, so it means, let's see, where was it? So when hypothesis is value is greater than alpha level, so with actually hypothesis p-value is smaller than alpha level, we reject null hypothesis. So we have favor to the interpretations. We don't write down the interpretation on my test or AP exam. You have favor toward alternative hypothesis, right? So in that case, um, where was it? Let me read from here. If the true population blemished potato shipment was population was 0.09, we made type 2 error by failing to reject null hypothesis based on the sample data. Of course, we also made type 2 error if the proportion is 0.11 or proportion 0.15. The probability to making a type 2 error depends on the several factors, including actual value of the parameter. In potato chip example, our tester will be more likely to reject null hypothesis uh, uh, p equals 0.0 in favor of alternative hypothesis. P is greater than 0.08. If the true proportion of blemished potato in the shipment is 0.11, then if it is P equals 0.09, why? Because this is much higher, right? And because 0.11 is farther away from the null value than 0.09, okay? So we will be less likely to make type 2 error if 11% of potato is shipment are blemished than if only 9% are blemished, okay? So high probability of type 2 error for specific alternate parameter value means the test is not sensitive enough to usually detect the alternative. It is more common to report the probability that significant test does reject null hypothesis when the alternative parameter value is true. So when alternative parameter value is true, there is a probability test that significant test as reject null hypothesis. That probability is called power, and power of the test is the name of the test. So we'll show you how to run the power of test. Anyway, so you can read the definition here. So that's the definition of power test. This is the example. So it's a potato chip company example. So potato chip producer wonders whether the significance test, null hypothesis, p equals 0.08 versus alternative hypothesis, p is greater than 0.08, based on random sample of 500 potatoes, has enough power to detect shipment with say 11%. So they decide for the probability of this power test when 11%. So there are two types of questions and within one question. So just remember that. Okay. In this case, a particular type 2 error is fail to reject null hypothesis. P equals 0.08 when P equals 0.11. On the next page, show two sampling distribution of P hat. One when P equals 0.08 and the other one is P equals 0.11. I think we did P equals 0.08, but let's think about this. We could do the exactly same thing of the, let's see, 0.08. So we kind of make a normal distribution here. 0.08 is a P, right? Now, that was, we consider that as a true P, right? And standard deviation is, let's see. So standard deviation of 500 sample is going to be, let me write down here. So I think we can use sigma here, right? Because it's the value of p hat, so it's maybe standard error. Okay, let's just don't want you to get confused with let's use the standard deviation. So I put the sigma sign here. If I incorrect, I will make an announcement. So the sigma sign here is sigma. Okay. So sigma equal. So the square root. So let me go back to the page. Square root success is 0.08 times, just put times here. Failure is 0.82. To find, we consider to find a blemished potato is success. Failure is to find the good potatoes is kind of the other way around, the failure. Divide by 500. So this is going to be standard deviation of this distribution. So let's see. So let me write down. So square root 0.08 times 0.92. Sorry. 0.08 times 0.92, close the bracket, divide by 500. So most likely standard deviation is right here, 0.12. Okay, so I will put in here. So one standard deviation above is 0.092. You should just add this number. So it's going to be, it's if you use a normal curve here. All right, now type 1 error is same as alpha level, so 5%. 5% of distribution, where's this green cutoff line of the percentage we are expecting for the cutoff, right? So that is, you can go to normal, let's see, maybe invert norm, right? So if you type in invert norm and set that place 5% and this mu, not but p hat. Let's see if it works. Invert norm here. The area here is 0.05. It's one tail, so 0.05. Enter. Mu is 0.08, which is p, right? Now, standard deviation is 0.0121. Okay. Now it's going to be right-hand side tail, so I will select this one right-hand side. Enter. Paste. Paste. The cutoff line is 0.099. So we assume this cutoff line is 0.10. I'm sorry, 0.10. Okay. So let me bring this window. So I wanted you to remember how I got the standard deviation. And I want you to remember how I got this distribution. Cutoff line is 0.10. So p hat, now they use p hat. So it's maybe I should consider this one. I wrote down this is standard deviation, but what did I write? Maybe I didn't write down the equation. But anyway, so this is the standard error, SE, okay? Now, SE is gonna be here, standard error. That is cutoff line for type 1 error. So if you move this one, same line here, P hat is 0.10. And consider this is going to be the second question, right? So the second question is, what if this is the alternative percentage, 11% is true? So let's run the standard deviation for that, right? So same thing, standard, maybe standard error we can call. Now, standard error, so let me clean up here, is 0. Square root, parenthesis, 0.11, that's success. Failure is complement of this, so 0.89. Close the bracket, divide by same amounts for 500. So this is standard deviation of the mu is 11. So take a look. So this is right here, right? Now, so cutoff line is here. So let's see, this is the cutoff line and positive infinity is going to be this. So what's the percentage of this highlighted area, right? So that is actually, let's see. So that's the distribution, let's see. So that's, let me think, this is second bar and normal CDF, right? So cutoff line is start from 0.10. Upper is infinity, 1 E 99, and mu is 0.11. Okay, I forgot the standard deviation. Just I cheated here. Just 0.013, yes, 0.14. 0.014 and paste it. Okay, this is a standard 0.0139. So there I put 0.014 for standard deviation. So now let's enter this. 76%. So that is the power of test to detect alternative power of test to detect that the P equal 11. So when no hypothesis false and P equal 11 is true, this is the area Okay, so if no hypothesis is false, right, and the decision to fail to reject no hypothesis based on the data is type 2 error. So this blank part is type 2 error. How did you get type 2 error? 1 minus the power of test. So this is probability to, so it's okay to reject no hypothesis because 0.11 is true, but this is the power. So if you have a equation somewhere, you can read this, you can pose it. This is page 565. So the probability of making a type 2 error is white area is 1 minus 0.7626. What is the value of the highlighted section? That is called power, okay? Which is, what's the power means? That means, where was it? Right here. So that is a power, okay? This is the definition of power. I hope you understand. So there is one more thing. We use alpha for alpha level, significant level, but there is a power and type 2 error. The power of the test against any alternative is 1 minus probability of test type 2 error, and for the alternative, that is power equal 1 minus beta. So now, so type 2 error, the probability of making type 2 error, sometimes we call it beta. So this I would like you to remember, okay? That's it for today. And this is weekend music for you. And I hope if you have any questions, please stop by my office hours during my office hours. Okay. This is called Mambo In. I forgot to share. Huh? Have a nice weekend.